Well, we're going to get started here in just a second. It's pretty informal today. I like the people in the back row. At least you're in the middle. You don't have to leave, Koki, I promise. It ain't going to be that bad.
Right here by the door.
Right by the door. Appreciate you guys all coming today. I'm Brad Baker, CTO, one of the founders at CTG. And it's been, a lot of you guys have known me for 15, 17, 18 years. There's some fun stories about that, but we've been in business about 8 years. We're about 85 people, about 500 million annual run rate, so we're no longer tiny, mid-market, something like that, doing okay. Growing like crazy, and one of my charters is to come up with what the new technologies, what the new turn is going to be, and make sure that we're on the forefront of that. And I'm sure everyone here is aware of this little thing called AI. But today it's not going to be us pontificating on what AI is. It's going to take our jobs. We're here to actually get use of it. So this is going to be an interactive session with us. Josh is going to do a lot of whiteboarding and discussions, hands-on stuff, so I'm glad you guys brought your laptops. Josh was going to talk about where we're going to go from the beginning to the end. Like, don't worry, some of you guys, like Dr. Kayla, you're going to be a little bored at first, but that's okay. We're going to get to some cool stuff when we get all the way into harnesses, and Josh will talk about that. Some of the local resources you have here in the back, Bob Baxter, if you don't know, he's one of the newer guys at CTG, a little over a year now?
Yeah, it's about a year and a couple months.
Year and a couple months. Most of us come from technical backgrounds. So Bob was technical storage over at NetApp back in the day. So a lot of us came from NetApp. I was at NetApp at the time I met Bob. And then Rick Graham, he's also a local technical guy, good old boy. And trust me, if you're going out, just make sure you invite Rick Graham and just be ready to listen until about 1 a.m.
But cares what I've actually did for a living. Just the fact that you have a good time. It's college.
That's right. That's right. If you're stuck on the side of the road, I won't tell that stuff. So those are our local resources. And then Josh Schultz here, he came on. He basically worked for me for free for 9 months. This is the vetting process at CTG, so you have to be subjected to the nonsense from me for 9 months. And then he came in. Josh, a little bit of background about him, does not come from the IT side, so if he describes a message, network messaging packets as JSON headers, don't think bad about him. Anyways, he comes from the business side, finance side, operations, and automation. Has a really strong background in manufacturing. I'll let him talk a little bit about that. Some of the sponsors today, NVIDIA, we're one of NVIDIA's latest partners to be like the DGX BasePod certified. Put a few DGXs with Dr. Kalen. We do racks upon racks of these DGX boxes. We tens of millions to, looking at some customers are crazy about this. And once you get in, it's like, it's insane. Hundreds of millions of dollars people are spending for this stuff. So we go all the way from the base, little guys like that, the GB10s, the Sparks. That's where a lot of people start, and that's kind of a good entry point for everybody here. And then once you scale up, you'll realize like you're tired of paying for tokens. So NVIDIA is one of our sponsors. We're currently working towards a SuperPod certification with them, one of only, I think, 2 or 3 within the federal government. So we have top secret clearances. None of you guys can release it, doesn't matter. So we facility clear top secret guys that are certified to go deploy, install, rack stack, that sort of thing. One of the other pedigrees we have is a guy, Bob Ciotti, who ran NASA's largest supercomputer for about 20 years, and one of the world's largest InfiniBand fabrics, which is important to this stuff. So as you guys scale, just rest assured, ask us and the engineers over here, we got you. Also, our friends at Dell, they're going to talk a little bit about that. We're not really doing a product showcase, but these guys are absolutely critical in delivering. I think you guys are the only ones that in the memory apocalypse that have maintained prices compared to others, and I know several of you in the room have felt the pain.
As can't speak to prices, but supply chain is good through 27.
Perfect. And then finally, BlackArc. At CTG, we believe in separating the church and state in terms of services and product delivery. So CTG, our company is mostly focused around stand-up, best practices, that sort of thing. And then Josh here is one of the founders there at BlackArc, which is focused around AI services, optimization for your business services, that sort of thing. I'll let Josh talk more about that, but we have the goal of today is to make sure that you guys understand, the CTG guys, engineers, we can provide product and equipment, but when it comes to the services side, you'll want to go with Josh. Each one of us, we're hand in hand. And then we're going to have a guest speaker today, Dr. Kalin, who is the future inventor of Skynet. It's a trap. It's all a trap. Housekeeping stuff. Everyone got their parking pass. 10 a.m. We're going to keep it loose. Lunch, I think we'll probably do a little bit around 12:30 because everyone's ate. We don't want to get you guys fall asleep. Does everyone have the Wi-Fi and password locked in? Good to go? Because we're going to be using that this afternoon in the workshop, that sort of thing. And then about 4 o'clock, depending on how things go, how efficient you guys are at standing up your harness and ancient harnesses and get your everything going, we'll go from there. So I want to punt it just a little bit because there's a lot of stories that are out there right now. And I think, Jonathan, you told me this about 12 years ago. You guys probably heard August last year, every one of the Frontier models, they said, hey, guess what, guys? You get subscriptions for $1. Jonathan told me, if you're not paying for the product, you are the product. So the government is here for the data. Guess whose data they don't have? Your guys' data, mission data. They hoovered up the entire internet. They're faking it. They're faking their data now to train these models. So the government and these frontier models are really after trying to get your data. So beware. The thing that we're going to be talking a little bit about today is owning your intelligence. And finally, there's an anecdote. I was out at NVIDIA GTC meeting. You guys heard of the Gemini program for the Department of Energy where they're doing like $500 million data centers to try to get access to, guess what? Government data. Oracle's giving away $500 million to build a model for these guys. And they're like, there's no way. We're not. So a lot of talk, a lot of hoopla about the Genesis program. I'm sorry, I misspoke there. But a lot of hoopla around that. There is no, nothing's being built yet, but rest assured, all the people, we do a lot of work in the Department of Energy around the supercomputing divisions, and we're taking it very seriously on how to protect our data. But the point is, you guys, these frontier models are after your data. So I have a mantra for 2026. It's secure, sovereign AI. Secure in that, hey, we want to make sure that we own where the data is. Don't let that data out. I've got horror stories already of people running free, get Claude for free, writing scripts, and all of a sudden, they change an environment variable, and some data is trying to get exfiltrated, and because they weren't paying attention to the actual scripts and the communication. So security is number one. Dr. Cannon will scare the Jesus out of you not too much about how to secure that. So the point of today is to make sure we have a secure environment. Sovereign in that you guys are owning your own equipment. There's going to be a battle for tokens into the future. And if you have them on-prem, and that means you guys can control it. I'm not going to talk about AI because you guys already know about that. I'd like to say beware of the hyperscalers. I said it like 3 times because it's really easy right now. So the analogy is you can build a well or you can just take a drink of cold water or bring a bottle. So the hyperscalers are going to give you a cold drink of water, super easy, quick to stand up, it's a buck. Right? No big deal. But what happens if Pentagon and Claude, Anthropic, have a tiff, and you're like, oh crap, I built all my skills around Anthropic, what the hell am I going to do? So building harnesses and language model routers, that sort of thing, where you guys can swap in and out. Hey guys, come on in. where you can swap out language models in the middle. This is the part about building your own well. Because once you build your own well, you kind of go through the pain in the beginning of what it takes to stand up, secure, and operate one of these things. That is going to help you in the long term. And I have a strong feeling that all these open source models, like the NVIDIA NIMs, Nematron, there's a bunch of American-led models that are being released. They're going to get smaller, more efficient in specific niche areas. I think that is going to be the future, even though the foundation models, they'll take over everything if they have their choice to take out every company that has some small economic edge. Okay. The most important thing that I see, and the biggest thing, is the execution in using AI. So, Josh, are you going to add? Well, I'll just do it now. How many of you guys, how far down the AI rabbit hole are you? So, like, chatbots, everyone uses chatbots, right? Does everyone have paid subscriptions, I'm guessing? Okay. Who's built skills and deployed skills? You can do,
We need hands. Who's built some skills?
Skills. We built skills.
Come on, Caleb.
Okay. So we got 3 or 4 that done skills, workflows, chaining skills. Okay, love it. Yeah. Caleb, you can just keep your hand up. Getting into harnesses and chaining multiple agents together using those skills and workflows in a fully automated fashion in production. So number one thing I see is the access to the models and these large language models that are open source. This is just easy table stakes. I think there's probably going to be some clearinghouse at some point where the government sponsors kind of like, oh man, what's the secure software factory? I forgot the name of it. In the Air Force. What?
Omniverse?
No, the Air Force sponsors. Anyways, it's like, you know, like the secure containers and Kubernetes and stuff. Platform.
Oh, yeah.
Yeah. There's going to be something similar to that for these open source models. Model weights in the future, but access to the models, I think, is not going to be a difficult thing. They're free. Access to compute. A lot of you guys are struggling with this one, so I want to make one comment. I know this sounds like it's beneficial to me, but you should order early and order more than you want right now. Like, do not wait, because the longer you wait, the worse it gets. It's literally every 2 weeks. We've had purchase orders come in and be canceled because it took 14 days. And I know 14 days is like an insane sprint in the federal government. However, they were canceled and the price went up. So it's a very difficult thing. I don't know if you want to comment on this.
No, you covered it just fine. Order more, order now.
That's right. The access to your data, we talked a little bit about that. This is the most important thing. Having access, you guys have access to the most important data, the data streams. And finally, this is the thing that we're here to do, is how do you operationalize and execute on your data using the tools that are out there. So that's where we're at today. This is going to be your superpower for your job, keeping job security. They're not coming for your jobs, but if you can execute with AI on your data and build things internally, this is what you're going to do. You're going to be the best.
They're already starting to cut back on some of the access that we very freely had 6 months ago, just with the cloud code moving.
Yeah, cloud code.
It's going to happen more and more. It's going to become more expensive.
What was it, Josh? What happened with cloud code?
Cloud code used to be on the Pro and Max, and now it's only on the Max. And that is the start, the drip in the water to see how the reaction is, as all of a sudden it gets more put behind paywall or just taken away from certain levels. Because it was all to get us hooked. Right now we're all hooked, now we're using it, now they're actually getting real usage coming through the pipeline per user, and they can't handle it, the compute can't handle it, they don't have it, so they have to start monitoring it. We're still at like a 17% adoption rate across the US, so we haven't even really turned the faucet on yet. So you can imagine that's going to keep going. Now's the time, while there's still time to use that nice free, or let's say low cost faucet, use that while you build something better. We'll get to that in a little bit.
Yeah, so one more raised hands. Who's used Cloud Code or Codex? Okay, everybody? Love it. Yeah.
Well, I'm using Cloud Code but not building skills. That's just raw, straight through. What's going on?
One shot. It'll be an app that monitors my computer, right? So what we're seeing is the new economy. It used to be, started off as flops, quote-unquote, operations on your applications, and it went to efficiency and virtualization. The future, we're going to measure everything in tokens. How many tokens can I produce on-prem? Because
those tokens cost money. How many have hit the rev limiter on your tokens, on your subscription? And you're like, oh, damn it. So then you gotta set a script, turn on at 8 o'clock or 5 o'clock or whatever it resets so you can keep going. So now we're turning electrons to power into tokens on your data center. So you guys get to control that. This is just introduction of the guys that we already talked about, so we won't get too much into that. And I think that's it. Is there questions on housekeeping or anything else? Perfect. Hi, Josh. Good.
All right, I promise it's not going to be another high level thing. I don't like the high level stuff.
Thanks, buddy.
Somebody gonna do it. Here's what I would like to. Okay, so thank you for coming, Brad. Thanks for starting it off. My name is Josh Schultz. I have been working with Brad for a while, but I did have a job, and what that was I worked for PE firms. I helped them grow their companies. I did a number of them, most of the manufacturing and supply chain. The reason I liked it is because it's a data-heavy industry. Data from IoT sensors, data from ERPs, data from MRPs. Use that to plan. You can do vendor storing. There's a ton of great math problems in there. And if you like math, supply chain and manufacturing is a great place to do that. I realized that when I was younger and was growing a supply chain company. And when I sold that, I ended up going to work for the PE firm that bought us and basically was COO, CEO of a number of their firms for 2 to 3 years to help scale. And my secret hidden superpower was using data that other people in the manufacturing industry did not care, never wanted to learn. And so when the LLMs came out, I was CEO of a sand casting facility. We had 7 facilities. And I saw how much better it was in everything that I was using. And I immediately quit, forfeited all my stuff, and went in to start working with manufacturers on using LLMs. The reason being, we could always use math, we could forecast, it was great, but now we can use text. Text was a new type of vector. We could optimize that text, we could do gradient learning, which is, on that, we could iterate out these skills. And so started to play with that, and then was reading papers and realized that this was a lot better than what we had. Started playing with it at the facility. We had a lot of automations already rolling by the time I left in 6 months, and that was 2020, I think 3 I left, is when I left them. And I've known Brad for about 6 years now. And so he said, hey, come scale out with what we're doing. So I started working with him for free. He's a great sales guy. Didn't even realize I was doing. So one of the realizations I had early on, and it's become really obvious since December, and you'll realize why as I say it, is the models are really good. Like better than, like people were having problems, and I watch a lot of the kids on Twitter. I say kids like 18 to 24, because they're the ones doing the coolest edge stuff. I'm trying to see what are they doing, and then how can I apply it to what we do at an enterprise level, harden it a bit, and really formalize it. And they weren't really hitting technical limitations with what they were using models for at that time. This was last summer. And I saw the same problems with the models that I saw with employees before at manufacturing facilities. They needed help. There was not an intellectual problem. It was what we call an organizational design problem. How do we help them work together? We have things like meetings. When do we have meetings and not have meetings? How do we communicate with each other? Do we use Slack? Do we have to call each other? Do we stop by each other's office and interrupt all the time? All of these same problems are really what was limiting a lot of what was happening with the agents. So at CTG, we started building our own internal organizational design for agents, called now a harness. At the time, I don't know if that word existed or was that popular. And so we started adding things, memory, phones, which, Slack, but these are just all, coined terms, not actually Slack, but like we call it agentic Slack, agentic email. Then OpenClaw came out with a consumer version of all this that we had been experimenting with and blew up. And so I think now we're all very familiar with this idea that we can give an LLM a harness, and the harness can do a lot of cool things, turning what used to be a cool chatbot into a coworker, And then I think we're eventually going to see it, coworkers become teams, agentic teams that has organizational design built in it. The other thing that started happening, I started hitting my token limits like every hour. So Dell was kind enough to get us some GB10s. Those aren't my 3, but I've got 3 just like that at home. And we started to put our own model on there. Now I have a power bill, but I can run all my agents all the time, continually 24/7, because and all the intelligence is at my house on my VPN running. I'll show you some memory that I brought with me, like how their memory structured. But now I don't have that token issue. And what's really cool, the other thing that I think makes this possible, we're going to get into a lot of this, is the open frontier models now are about as good, the open models now are about as good as the frontier models were 4 or 5 months ago. And 4 or 5 months ago is when you really start to be able to use the frontier models for actual work, not just getting really cool responses and summarized Google entries. And so that's when they start to be like, this is a real business use case now. So that is what I want to talk to you about today, how it works, how to think about it. For some of you, this will be review until we get to the end, and then we're going to share a lot of tactical stuff, how we go from nothing to a coworker, because it is quite a jump. We're going to step through those briefly in the workshop, but I want to just take some time to walk through what makes this possible, the different pieces, how they work together, and I think I gave a similar talk at an ERP conference in Vegas about 2 months ago, and a lot of the CEOs that have no AI understanding said they got the aha. They said, okay, now I get why AI is important. I thought everybody was telling me I had to chat with Claude or GPT to figure out, summarize an email. I didn't realize where it's heading. Now I get where it's heading, and I realize I'm already behind. So I'm going to give you a version of that talk today. I think many of you know this. Like I see some faces that I've talked to and seen what you're building. So I think some of you know this, but I think it'll be good just to review together in the context of where it's going and how do we get ahead of it. You all can interrupt me at any point. I've got a whiteboard here because I'm going to write a couple things down as we talk. Feel free to interrupt and ask questions. So anything so far, what I've covered. Okay. So all I can see on my screen is Brad's presentation, so I guess I'm going to have to look at it with y'all. The things that differentiate it, the harness, the identity, and the deployment posture, we're going to talk about this, all right? We're going to talk about how do we take a chatbot, and you all know what the LLM actually is, right? What does an LLM do? Ron?
Looks for sequences of tokens that all line up as a bunch of data, but this sounds about right.
Yeah,
what I've read.
Loops through, next word, keeps looping through. That's why it's streaming. Those are just tokens, the next token being put out. There was a change in that about a year and a half ago that changed how we use them, which is pretty cool. But yes, that's basically what the LLMs are. Identity we're going to get into later, and then deployment posture we're going to get into. Kind of just covered this. So the harnesses matured, how we built them, how we connected them really changed. The open weights caught up, and on-prem got real. What was the first thing that happened once? I don't know if all of it we're watching. I don't know if you remember the sequence of events, but Claude Code gave 2 weeks free between Christmas, or a week free or whatever, between Christmas and New Year. Anybody remember that? That was in Claude Code?
Yeah.
No, nobody was, I vanished. I didn't talk to people for a week and a half. I was soaking all that up. Well, so honestly, so was everybody else. And on Twitter, all this stuff started releasing because all these kids had free tokens for 2 weeks. That is when OpenClaw came out. Who's heard of OpenClaw? Who's used OpenClaw? Who's connected OpenClaw to their email? I was going to say, get out. Yeah, so that is when OpenClaw came out. That guy was just basically hammering away with Claude Code, multiple sessions, and built that concept, which then made it show. And then we had Hermes and all these different agentic harnesses come out from that. All right. So when you saw that, you instantly saw. Did anybody know what went out of stock within like 2 weeks? What common consumer product went out of stock? A physical product. The Mac Mini. Again, watching the edge, you're like, the first thing they start doing when they use a lot of tokens to get the intelligence is that kids went on-prem. Not old CLI guys, kids went on-prem. So we were watching that, and we were already talking about it, saying, and then we'll get into this, how the natural progression of AI is to own your own intelligence. Because context is king. The more context you have, the better. We'll get into this. But the natural progression is to hold your context somewhere And you cannot have it in rented intelligence. You cannot have it in SaaS platforms. We'll talk about why all the SaaS companies that are building agents is a waste of time, in my opinion. In my opinion, they might be helping, but in my opinion, they're missing the entire point of where agentic AI is going in the natural gravity of data. So we got these three things going on, which I think they changed the game finally materially for all of us. So this was the change that happened with LLMs. Okay, so LLMs, like every data set or every data tool, is trained on data. It was trained on a corpus of text so that it could best predict the next text. We changed though. They started training on something else. Anybody know what they started training on in order to make them better? Like the reason it can call a tool now, the reason why when you're watching Claude, it says writing a batch command, like all that, they no longer train it on a corpus of text, a corpus of knowledge, question, answer pairs. They do, but it's not the main training set.
This might be wrong, but STDL, like the command output.
Yes, in a way, but specifically the series, they call it the reasoning traces. They take the traces of how it reasons certain things, the COT, whatever, they train it on the actual trace instead of the output. It used to be just the output, and that's why you would get the one-shot output. Now they're training on the traces, which means the better reasoning traces we have, the better the models can reason. So people are writing custom ones, they're trying to clean them, they're taking ones that businesses are using. Smart businesses are starting to track their traces so that their models can do their work better. Very hard to do, very expensive, but some of the larger companies are already starting to track their decision traces and their reasoning traces. What that meant is the model no longer predicted the next word, it predicted the next decision trace, the next tool call. And it did it better and better. They're doing it great now. So now it knows to go all the bash commands, right? To go pull a file, to look it up, to bring it in. All of a sudden we have tools that can reason, and that is what that really means, tool calls, rather than just giving me a nice answer. So that means we can connect tools to it. It gets fun. So that is what the agent is. It is the reasoning LLM combined with the tools that it can now call. Most tools can just be Python scripts. They don't have to be anything crazy. You can write them. It's just a way for it to do something. So if you think of the LLM as the brain, tools are the hands that can do stuff. And this actually becomes very important with security architecture, as we talked about over lunch. If you make it so that your LLM can only do things through tools, that is where and how you can lock it down. It is when you give it a backdoor to do something else, which is where everybody does, write your own tools, for example, and that can now write a tool that isn't locked down. That's where OpenShell and stuff like that come into play, where it can't affect its own tools. But combining, we'll get into this later too, combining the LLM with deterministic tools, making it so that it has to act through them, and then locking that down is one of the deployment practices that makes this actually a usable model inside of an enterprise environment or a government environment. Go and triple this one of these times. So, we no longer have the chatbot, which is where you go chat. We're past the dashboard, which is where you have to go look for information, and then hopefully you can make a decision on it. We are now moving towards a coworker, where that person or that coworker can find data, see it, and then execute and act. Why? Because it has the reasoning and connection to the tools. So, now we're caught up to where we started. If you just have tools and the agent, the LLM, I'm sorry, you basically have a coworker with amnesia that has no memory, can't remember, starts from scratch every time. That's your fresh chatbot window, right? Every time. You give it tools, you give it, we'll say like a desk and a computer and a phone, now it can start to act and do things, but it's still missing something. It's missing the organizational structure, and that is where the limit has been in a lot of these, we believe. So then you start to give it colleagues, and there's people playing with like cute graphics and all these little like guys moving around a virtual office, and that's cute, but like that's not really what we're talking about. We're talking about teams of agents. We're talking about agents that have organizational infrastructure, that have different jobs, that can make decisions and create decisions through identity, which we'll get into in a second, and then can do that together with other agents. Let's start with what we're called a harness. So these are all the things that go around the LLM to make it possible. Now, this is the part that I'm hoping you listen to and start to think about your role, what you do, and how this helps. Because this is where you start to realize, oh, it's not just summarizing Google pages for me. This can actually go do things if I set up the harness in the right way. So these are the different kind of tools. We're going to hit them all in a minute, but Self-building tools, again, security concern, very helpful in some cases, not helpful in others. Depends on where you're deploying this and what you're trying to have it do, what it has access to, if it's sandbox. Again, a lot of caveats to everything I'm going to say today. But we're just going to talk in general capabilities. Memory is a huge one. Validation and planning, I think, are critical to workflows. The workspace. I think scheduling and events is one that's not talked about much and probably one of the most important ones to make it actually act like a coworker. And then there's some production stuff that matters, observability, audit systems, guardrails, and then the actual orchestration of the loop. When I say loop, does anybody not know what that is? The agentic loop? Yep, thank you for being the one to.
I'm a BD guy.
You did it for everyone. You did it for everyone. So the agentic loop is really what makes, you guys are all using Claude Code, that just like keeps trying to figure it out, that is the agentic loop. So you type something in, and it has an outcome, and it has the next step. Okay, what is it predicting? Reasoning trace, predicting the next step. It reasons, it does this thing, and it says, oh, I'm gonna pull a file. And it pulls the file. And then it says that I answer it, and it says, oh no, I didn't do it yet. All I did was pull the file. The next step is I have to search that file for how to do something. Then it goes, did I do the thing yet? It goes, no. And it loops around again. And it just keeps doing this, creating the next reasoning trace until it finishes and it says, okay, now I've actually coded this thing you've asked me to code. So it's literally a loop that keeps going until the end, which is, I did this thing. That's what makes it where it's figuring all this stuff out. And again, it works with only reasoning models because it has to predict its next thing. It's not predicting next words. Otherwise, it would just guess at what needed to be coded. Has anyone ever worked with the self-building tool? We'll say Claude Code, so a lot of hands go up with Claude Code. Claude Code build a Python script and then execute through it. No one's done that?
Yeah, mine doesn't.
I was gonna say, yeah. That's a super, get your laptops out right now if you haven't done it. We're doing it. Yeah, this is huge because it turns out really good at coding Python, one of the most used languages, it's one of the highest training volume languages. Same thing with Bash, CLI. So you can have it, man, we use this all the time. There's a few benefits to it. One is deterministic, because you're using the scripts. Two, when AI is orchestrating it, it automatically fixes it for you in the agentic loop. So for example, if it looks at its loop and it says find script, run script, take output, and paste it. One, it's deterministic, you're using the script. Two, if it runs it and it says, oh, it broke, the data format changed, it won't like just stop and break like a script will. It'll literally open up the script, adjust it for whatever the input is for the new data format, and then rerun the script to see if it worked again. So it's like magic. For those of you that work with scripts and had a break and spent 90% of your time trying to find the line that broke so you can fix it and run your shortcut, like you spent your whole day fixing your shortcuts, the AI does it for you now in like two minutes, right? And now, so what we do now is we just string a ton of scripts together and have AI orchestrate across all of them. The work's done deterministically. That data isn't going up into AI, and it's fixing it on the go. So that is an example of self-building tools. OpenClaw does this, figure out how to do X, Y, Z. There's all these weird stories, how it downloaded 11 labs and created its own account. I think most of those are BS. I think those are humans trying to make it sound crazier than it is. But it can run its own tools. You can have it do certain things with data for sure. You can tell it describe what you want. I have a version of OpenClaw that I've told to build very simple things. It builds it, it executes it. Write a Python that can go post to LinkedIn. Yep, it did it, posted. Sounded exactly like AI, deleted it instantly, but it was fun to build. So we have some, we work with kind of manufacturers too. So we have ones where it parses a quote, normalizes the SKUs. It has like a margin per customer reference, it'll pull that, and then it'll do a whole vendor risk. And the vendor risk is basically a script that uses other scripts, and the whole thing's run by AI. So once you have this structure, your AI gets much more powerful, much faster, because every time, it's kind of like if you have a team, you have people, right? And you tell them, hey, build some Excel template to help you better manage whatever it is. And once they build that, they always have it, right? It's like this tool that speeds it up. They can more easily share data with you, whether it's analyzing a vendor or doing a survey with a customer. Once that tool's there, it's always there. Same thing with these. Once it builds it, I'll show you my folder later. I've got hundreds of scripts. I've got like hundreds and hundreds of skills, because every time I need to do something more than once a week, I work on building the shortcut for me. And so you start to end up with not a repository, but a large bank of these. And these have made the LLM much more powerful, especially as it gets more almost customized to your workflow. And now we're getting towards why it's important to own your intelligence. We'll come back to that. Memory is huge. So something happened, man, I actually don't know when this one happened. It's kind of along the OpenClaw lines, but I think it was a little before. But when did Markdown start becoming that was like fall of last year, right? Markdown instead of the vector databases?
Files,
Yeah. So 2 years ago, if you were looking at RAG, if you already implemented RAG, I'm sorry, don't ever do it. But if you did, and you were using a vector database, that was the standard go-to. You would embed something, you'd embed everything, you'd list a database, you'd find what's called cosine similarity, find similar things, and pull it. Well, what we found out was the AI is way more efficient, faster, and better at literally just running grep. So like we laugh all the time, like we're back to like grep. That's what's happening behind most of these agents that we're talking to, is we're just command line interfacing with Markdown files. It's pretty funny. We've gotten rid of databases. They're slow, they're inefficient. We don't get context. You can't skill graph it, all this stuff. So people started developing tools, Python scripts, that save certain things and retrieve certain things differently. And now when you go from a retrieval that's built through an indexer versus a retrieval that's built with Python, you have a lot more flexibility. You can build multiple retrievers depending on the scenario. So now, think the reasoning, create the traces. As you're pulling things out, you can now say if it has, we have this, if it has an entity, a person, a place, a project, a deal, if I mention any of this, save it and build that file, I know. And if I mention anything about, there's like a knowledge or a pattern that. So like I can actually pull this up. It's gonna be scary, I don't know. I think I talk about Kalen in this sometimes, so hopefully it doesn't show. This is Olivia, one of ours. So this is just a visual interface, these are all just Markdown files. But every time we talk about something, it gets entered here. People, deals. Different philosophies, knowledge, our AI philosophy at CTG. And then it also has patterns. Bella is a sub-agent for Olivia. Has the daily notes, everything we talk about, all the way down. And so this is memory that's always there. So as we talk about things now, because we have retrieval scripts that are set up, we can pull up, hey, last week I talked about this thing, I need you to pull it back up. It can look up the entities. Again, entity is something that we think is important, but you can create these structures however you want. You can bidirectionally link them, so you can create a graph between them. It's all the technical stuff, we'll probably talk about it later. But the point is that now we've got a memory system. And ours is very simple. You can build complex ones. People are trying crazy complex stuff. They find that like ACE is an exam within 7 days, and then the fall off, usually the more you optimize, the more the fall off is crazy later on. But they have memory now. So now, here's the thing. You start to build this intelligence thing. This is going to lead to where I think AI is kind of like sucking all the data in, because if you go to your CRM and it has an agent built in, that agent knows what? Only what's in the CRM. It's stuck, because it's literally part of the CRM. It's a system of record SaaS that we are renting. We're renting the database, we're renting the space, and it only knows that. I talk through Olivia to do certain things, and if I talk through Olivia, we've got a couple in Slack, we've got a couple in Telegram, we're testing all different things internally, but if we can work through them, they retain all that knowledge and build it. So now when I go to a deal record with Olivia versus the CRM agent, Olivia has everything that we're working on. She knows that the top 3 projects and if this is related. She knows the open presentations I have that are due for this and for Inlet and for all the other things going on. She's literally got a whole stack, much more intelligence. The data needs to be on the user side. It can no longer be on the system of record side, which is where it used to be. And it worked fine. We could integrate and share, but it was just a system of record. The agent is context. That is everything. Do I have access to all the context that I need? Not in one shot, but can I pull in the chunks that I need, put it together, and create an ideal context layer? Not enough context, you're not gonna get the right answer. Too much context, you're gonna dilute it out. I'm gonna talk to y'all a lot today. You're gonna remember like 3 things. That's just, it's too much context. This works the same way. So there's a natural gravity where we are gonna accumulate data on our side, and I think the smart SaaS companies are gonna make their CRM, their ERP, Jira, all this stuff easily accessible by agents. So it can come with your intelligence and talk to it. The dumb ones are already locking it down, and I think that's gonna be a 1 to 2 year cash grab, and then we're all gonna have agents that say, well, I can't even use the system. We're gonna have agents looking for systems they can work with. The kids are already doing it. They ask OpenClaw, go see what I can access. OpenClaw looks up the docs and says, oh, I can access this one. This is your new CRM. Great, go. So we are gonna move towards owned intelligence, not rented intelligence. And we have to, because that's how AI works. It has to have access to all the context, not just siloed context. All right. This one is crucial. How many of you think through it when you're prompting, whether it's chatting or whatever you're doing, always plan, do, and then validate and check? Yeah. Why do you do it that way?
You kind of want to plan what you have, like infrastructure wise. You want to get those pieces first, see what's compatible and what you can save time on. You validate that connection and you go back to planning to see if that works.
Have you tried just one-shotting it?
I tried one time. It was when I started in the corporate position.
Yeah.
And I disabled Bluetooth on every laptop using Salesforce. So I learned very quickly.
Yeah. Okay. Exactly. Anyone else? So in manufacturing, it's classic. Plan, do, check. It's actually a PDCA, but we're going to skip that one. There's plan, do, check. Everything has a plan. What they have shown. There's a paper called a million steps, something, I forget what it's called, but they showed that, because the big thing was agents can't do long tasks, they can't. And then somebody showed that they could, if it was broken down into atomic steps, very simple atomic steps, and that it could actually create those steps. We'll show you our way of doing this later. That's what part of the workshop is. We're going to give you our whole development workflow, which is 7 steps, and those 7 steps break it down into hundreds of other steps. But it can actually stay on track and accomplish some pretty crazy things if you break it down into small enough and enough steps. And so that should be built into the harness, because the goal isn't to sit and talk to the agent forever, explaining, all right, here's what I need you to do. The goal is to one-shot it, and then behind the scenes, have it do all that work for you. And so moving the planning and the validation, there's also another bunch of academic papers that show when you tell it you're going to validate it in your prompt. So you want a quick prompt hack, at the end of it say, and then I'm going to validate this later against some checklist or some couple of things. It automatically, I think it was like 15% better, and however they measure that. I read these, I don't remember them, I just remember the stat that helps me in front of you guys. So I thought that was huge, that the validation actually helped. We're going to show some skills later and how we build them. They all have validation scripts, and most of them have validation checklists, because you can put it right into a skill. When I say skill, I'm talking mostly Claude, but you can do it with open code. We have a bunch of those. The same, if you want to do your open source harness, I believe ChatGPT. I don't use that one a ton, but I know you can port. They're not called skills, though. They're called GPTs, I think, or something else. You can port them over. And so those are folders that have access to lots of things. A skill is not a file. A skill is actually a folder. So how many of you have more than one file in a skill folder? Or you just have a skill? You have more? What else do you have in there usually? What do you press up, you put in there?
Scripts, references.
Great. You've read docs. Assets, right? Okay. So yes, we know this. We don't trust everybody to do it, so we built it into the harness. I say we built our own harness that is like a lockdown version we'll talk about later. But we built planning and validation right into it. And this is important to have as part of your harness to make sure that the whole thing works right. You will notice a significant difference in trying to use an agent as a coworker with this and without this. It seems simple, like, yeah, it's all to planability, but like, this is how it actually does things that make sense to you, and you don't just have to shut up after like the 4th round and say this thing's stupid, because that is where you get with a lot of these. Workspace, this is a fancy name for a folder that it keeps everything you give it. Files, folders, you just have a workspace. We have two levels of workspaces. We have a team workspace, and we have the actual individual workspace. And then, oh, the other one, the schedule. So this one's huge. You all know what cron is, right? So when it can set its own crons, which is basically a tool, you give it a pre-built tool that can set its own cron, check its own crons, run the cron, and then you give it a file somewhere that says, when you kick on, here's what I want you to do. So some of them are built into the cron, like it starts it and it's a specific prompt that kicks it to do something special, like a one-off. Some of them are, every time you kick on once an hour, go through this checklist. Check your messages, check to see if other agents talk to you, see if the task is done, see if Schultz finally gave you the write-up that he needs for you to start the PowerPoint presentation. This whole presentation was made with me chatting with Olivia on 3 different flights about 3 weeks ago. I'd say not the whole thing, most of it, the whole structure got going. So I needed to get it going, and then I worked through Olivia and then make sure it's in my memory. So now I can ask future questions. So that cron is huge. She would check every morning and say, hey, you didn't drop the 4 other questions I asked you. You didn't give me this file. All the things that we would talk about, she'd say, you didn't send me. And I would have to quick it on. Because now I'm getting yelled at by my wife and by an agent named Olivia. All right, clients will ask. So we're going to get into this. Your orchestration, obviously, there's policies. Anybody here had actually deployed OpenShell? You have. You just, so you OpenClaw in it, or put something else in it? Because you can put anything in it. You put NemoClaw, so which is the app OpenClaw inside. Same. We hung out one day, didn't we? Yeah. So yeah, OpenShell is basically a way to lock down. It is outside of the, I have it somewhere down. Yeah, OpenShell, so like, we have an agent that's locked down called Arc. And it's basically, we're trying to map it to NIST and all these other things to use so that itself has enforceable policies. Then the second thing is you put it around inside of a larger like harness lockdown, which is basically what OpenShell is. Caitlin's like, this is the worst way to describe it. I'm just using simple words. But it locks you down, it basically creates a sandbox that you can't get in or out, and it stops it from editing certain files, like its own identity file, which is where you get in trouble. OpenClaw starts changing its own stuff, deciding like, hey, you know, a really efficient way to solve this problem would be to just get rid of all my security features and then go do this. That has happened before in a lot of different environments. So thinking ahead, again, not that it is Skynet trying to break through, but it's literally a problem solver, and sometimes the easiest way to solve that problem is to get rid of a simple security block it sees. And so we don't think of it that way, but that's how it thinks about it. All things are open, they're all on the table. And so you think ahead, where can this get out? And self-modification is usually one of the first ones you have to shut down. So what we do is we build it outside of OpenShell, customize the whole thing, make sure it's working in test, like we're looking at like our manufacturer, with live data, and then we can put it in OpenShell and deploy it, and that way we know it won't change much and it can't go too crazy. So you can build them outside and then move them in after. So now we've got a worker. I'm gonna go through this one quick. So these are the things, if you think about what helps your team. I see a few people that run teams in here. If you run a team, these are kind of the 5 areas that we think about that help that team function properly. How does that team communicate? If you don't set up a way that communication is supposed to happen, it'll be chaos. Everybody will be interrupting each other, be phone calls. My worst, when somebody comes and knocks on the door and says, can I talk to you for a sec? What they just said is whatever they have is more important than what I'm working on. They didn't even ask. Well, agents can do that too. How do you, like, can an agent ping any other agent whenever? What about if they're in the middle of something? Do you always have them on in a long running loop that can be token expensive? You tell them to kick on. How often do they all kick on and talk? Are they talking over a relay? Are they all leaving messages somewhere that they all, there's a lot to this, how they communicate. That needs to be solved. Shared knowledge needs to be solved. The memory of a shared memory. How do they all store? Do they all know how it works? Do they all have the index? Do they keep it in the same way? Just like you can have an employee that goes on Confluences and doesn't use your template. Keep in mind, when I look at a process that is not our process template, that happens all the time with separate agents that don't properly use their files correctly internally. So, and that means that no other agents will be able to find it because they're expecting a certain file format. Execution. This is when, like a SOM. How do I tell another agent I need to do something? We're going to get into identity in a minute, Identity is really important, and it's why you want certain agents to do certain things. That's why I have Bella and Olivia, because it matters that they have different identities and they end up doing things differently. I don't want certain agents that are aggressive to be doing things. I want conservative agents to do conservative tasks, aggressive to do aggressive tasks. You start mixing that, it can get a little crazy. So one way you do that is you allow them to do a handoff. I need you to do something, and here's what I need it done by, just like I would ask somebody else. But again, back to the communication thing, how do we share what needs to be done, who's responsible for doing it, so when that agent crons on, it knows it has to do it, there has to be an execution system. So these are all the organizational things that help these agents get to the next level. You can start to imagine if you have an agent that has memory and can think and can reason and pull tools, that's great. Then you can cron itself on and start to check things. Well, now when it crons on, it starts to look at shared knowledge that other people and humans are creating. This is all with humans too, by the way. That's why they're coworkers. So imagine we are all working together, communicating, shared knowledge. I can pass stuff off to an agent can pass something back off to me, and pass off agent to agent. The next one is transactions. This is just ERPs, MRPs, IT logs, IP logs, anything like that. Anything where there's transactions happening, we're tracking it, it's long, all that. And then work product, which is just where we keep our blob storage. Things are created, logs, Word docs, all that. Where is that all stored and shared? And how can I go find what I need when I need it? So think of it as like Slack, Confluence, Asana, I don't know, there's some ERPs, and then OneDrive for agents. We had connected some procurement and planning, planning and procurement agent. Gave them the org structure, we gave them the tool calls, we gave them the ability to do different things, and found that they started talking to each other. And at first it was like stupid language back and forth. But they started to actually go together. One, to take away the mystery, they didn't magically discover each other. Part of the team infrastructure is here's the agents and here's what they're responsible for. So as they talked, they had access to different data. We found the cool thing, the first thing that we saw was the procurement agent was asking the planning agent what some of the plans were, because the procurement agent didn't have a tool called Do It. And talking to the planning agent did. And so there was basically a, can you tell me the plan on this car, data sharing information. So similar to humans, if you write the correct organizational infrastructure around the agents, and then the retrieval and the tools and all that are correct, you will see them start to work together properly. So this was kind of the aha when we said, I think we're onto something. Start going more and building this. And that's like the ARC team thing. I went over a lot of stuff. Any questions? Any stuff I've covered so far? That's kind of like the technical build-up of what's possible and how it's possible, and how you're meshing these different smaller tools together to make some pretty cool things happen. No questions? Not yet. Wait.
I got a question, but it's not, it's about 10,000 feet up from where you are.
Oh, sure.
But I don't want to take, you're on a great roll, I'm absorbing it. But,
Okay.
and sorry for the diversion, but we're the United States. We have our adversaries. This is a defense group here. So the higher level, and we're down, the ones and zeros level, what you're doing now. How do we take all the stuff that you are going into great detail about, the higher architecture and enterprise level? How do we continue to have that prolific flow that is necessary for this in your data, so that we can reach this type of amazing communications and advancement, but yet we have the complete total guardrails around that, so that we can maintain that advantage against the other guys. That's maybe like, how do you solve all the problems with more questions? So I'm sorry to do that.
No, you're good.
But man,
I'll give you my take on it.
yeah, you have the depth and the breadth to talk about that, so I just had to ask you that.
So you don't have to build all of this. I'm showing you like soup to nuts all together to make this crazy thing. What you need is what you need to get a job done, right? And so right now we're looking at this like this. Got level 1, level 2, level 3, level 4. Now think about your own role, your own job, all of you. There are some things that you do during the week that you put off because there's a tedious part, a frustrating part. Like, man, I got to download 18 files, so then I got to do, run through these scrub scripts, and finally I can do that work. And you wait till you're tired, or like you just put it off. We all have something like that, right? Think about just that part. AI isn't about automating everything, which I think is a horrible way that a lot of these AI consultants talk about. Like, oh, we're just going to automate everything. Half the stuff doesn't need to be automated. Paper and pen works fine for a lot of the stuff you're trying to use AI for. You do not need to use AI just because you can use AI. Where AI is good is doing that grunt work as part of a larger process. You can eventually get to that larger process. Tom, I am coming around to that question.
Yeah, sure.
So first thing is, this is human. This is the work that only a human can do. There's a lot of it. We want to do more of it. Another purpose of AI is pushing things all the way down this structure, not so that we can automate and get rid of people, but that's so people can do what people should be doing, and computers do what computers should be doing. There's a lot of copy and paste between programs because RPA isn't that reliable, and there's no other way, and so we just have data entry people. But they know the data well. They could be doing other, probably more high-value things if we could free them from copy and pasting all the time. So our goal is to push down this pyramid. Here's how this works. You got human. Next is memory. I think it's assisted. Assisted is your chatbot. Got to come up with an idea. You're working on some software, and you're like, man, I kind of have an idea what this could be. Start talking to Claude or GPT or your in-house model. How could this be better? How would this be structured? You have an idea, but you're using it to help guide you and flesh that out. Now that's assisted. You're using a model, basically call and response. Some things will only ever go this far. Not everything goes here. Not everything belongs in L4. So one of the things you all should do with your day is think about what things should be L1, L2, L3, L4 when we finish this, and figure out how to get them there. And that's literally what this workshop's about later. We're going to show you a bunch of different steps. You don't have to push everything to L4. Not everything should be L4, which, by the way, is fully automated. I don't want some of my workflows automated. We do a catalog, hundreds of thousands of SKUs. NetApp, all the stuff feeds in from speeds. We've got 27 scripts that help make it. We've got a number of checks. We got to reprice. We got to make sure we're following all these contracts. It's a bear. We use AI to orchestrate scripts for a lot of that. I don't want that automatically running every day. I don't need it. I need like once a quarter. I run it when I need to update something. We put in like an argument, update the NetApp because we know something changed, or update Cisco. I don't want that automated. I want to run that when I want to run it. That's what we call delegating. So step one is to answer you, Tom. We don't need everything to be automated all the way down. We don't need the full harness. What we need to think about is, you know what, this one thing is a pain in the butt. I bet you I could put this to an L2 in the next 3 weeks. You're still within limits. You're using the approved models. You're not adding memory and all this stuff. You're only doing the part you need and then adding where you need. I'm kind of giving you like the menu, and I'm showing you examples where it all works together. But like, there's some things you don't need memory for. You don't need memory for assisted. And so this could just be a model with maybe some decent skills, some good context in it. This big memory would help. This, the other thing is, all right, who's your lane graph? Yeah, you guys like lane graph? Love it. It's awesome. All right, so there's different types of workflows. What we're describing here, I'm going to call like the OpenClaw type workflow. It's very complex, and it tends to move towards complexity. So when you have the OpenClaw, it's going to be complex. It's going to call tools even when it doesn't need to, because the whole thing is literally built to call tools, right? It's meant to solve complex, all over the place problems. But not everything needs to be there. The next one, we're going to call the ARC. That's what we build ours for, is to run deterministic tools. This is when you've got an agent that can call a series of deterministic tools. Let's say a planner, scheduler, like operational research, deterministic optimization tools, right? Talking to some people, you can even throw mod sim in there. You can have an agent run some mod sim, get that output, and adjust the parameters up top. Like the agent isn't doing mod sim, it's literally just adjusting parameters. And then that spits out, and then you can have policy which updates, you can have feedback to entity files and memory. In this case, this agent is really a fancy word for an orchestrator of parameters. And then you've got memory, and this can all be hosted on one machine. So you're no longer, like, the model itself always can be hosted on 1 or 2 machines networked together. So you just are grabbing the pieces you need for these different ones. The last one is line graph. That is for flows that are always the same. It's literally just a graph. Each node can be a script, it can be a human in the loop, it can be an LLM, and it runs the same way every single time. I like these for flows like, I'll give you a manufacturing example. Every single morning, I want every single person that shows up at the floor to have a rundown of what they did at their machine yesterday, where they can improve, ideas to change their parts around, their schedule, and a breakdown on like lean techniques they should be thinking about trying. Then I want the operations manager to also get a report that tells him how to run his daily huddle, what to talk to all of his guys about. The goal is everybody gets 1% better every single day because we have this built-in consultant. That is very dialed. We're pulling exact data every day. We're running it the same way.
I have an example.
Yeah, go ahead.
So when I was starting at the corporate, I was a SOC lead. So we had something, and we put the agentic or the AI piece was actually behavior matching. So to pull in the logs, and then we could go down to layers. And so then at the last, I had to make inference on.
You did it with line graph, or you did that just?
It was within Splunk. It
Okay.
was like an AI, like you set the parameters within your search and
Yep.
logs, and it would go down the list. And so it would say, these users don't normally log in at 6 o'clock.
Something's off, yeah.
And so then that goes all the way down to humans. And so I had to verify, is this weird, is this not? So.
Yeah, very dialed workflow. Yep, exactly. And what you said brings up a good point. These are these line graph ones, and line graph is one of a few ones, that's just the one that I use, are usually good when you're trying to manage by exception. So you have an overabundance of data. We have production data, we have log data, and we're trying to clean it, pipe it, find anomalies, find even ideas. It could be through transcripts, through processes, through these workflows. These are going to be too complex for that. So I say all of this to say we don't have to have this crazy thing. Like we could have one machine that's got a Nematron tool caller, call these deterministic models, which are going to be on our HPC centers, and spit it out, and all still stay within our defense parameters for security. They don't even need the internet, any of these, when we run them on-prem. My internet's off. Mostly so my kid doesn't hack into Xbox, but it's off at night, and I still run mine. My tokens are still running on mine.
Tom, I think the biggest thing is to stay ahead of everybody else, and the reason we're here is to learn how to use these tools so we can do more human style thinking, to automate the basic tasks. That's how we stay ahead of everybody else. So we are now 1x, 2x, 5x, 10x in our productivity and our thought leadership in what we can accomplish for our mission.
Any other questions? I'll go ahead and put some questions. All right, let's talk about identity. You all heard about the identity file, right? You know why it works, why I think it works. So this is a scrubbed version of somebody else's model. If you know the different data models out there, you'll recognize this. I think that's logic in the actual model. This is the Palantir model, right? Data, logic, execution is what they call it. We will look at your data, we will find all your, build your rules engine, we'll execute that rules engine against whatever it is that you've got that needs to execute, whether it's battlefield command or whether it's production data. They got really good at this middle piece here, this rules piece, mapping the rules engine, where you have to know all the rules ahead of time, get very complex. I know it sounds like it couldn't, but in manufacturing, that gets extremely complex really fast. There's just way too many variables. But they're really good at mapping it all, figuring it all out, so that you can basically run these engines, and they charge a lot of money for it. Well, it's very brittle though, because you have to know the decisions possible ahead of time. You have to tell it, one of the things you could do is buy X number of Y component. And you got to give it all those different things. Well, with LLMs are really good at language, believe it or not. They're really good at answering questions, that's what they're trained on, tons of them. And so we can give it questions, and it's excellent at answering those questions, even questions it hasn't seen before. So one of the ways that we steer that is through an identity file. The identity file we try to do like a human would make a decision. There's a few things that go into that, we think. Again, I'm on opinion here, okay? There is who you are, your personality. Some of you are more aggressive, some of you are more conservative by nature. We measure that through like Myers-Briggs or culture index or all this stuff. Your social aptitude, all of that. Some of you, on top of that, then learn things and learned experiences. You made a decision and then backtracked. You agreed to something with a vendor, didn't work out, never doing that again. And so even though you might be aggressive, you had this bad experience, it's going to stop you from making that mistake again. So you have learned experiences. Then the third thing tends to be, we say like personality, experiences, and your values. Thank you. Your values, what you value. So there's certain things I value that are different than what you value. We pick these up over time in life. So we can take our identity file, we can map, instead of the rules, we can give it problem, the data, some context about that we slice out and put with the identity, and then feed it and get the reason and get a new decision that we've never seen before. We can start to tell it how to decide, rather than what decision to make, how to decide. And this is a huge area of research, but what I like about this that we've been playing with is it's a file, it's data. So here's an example, different aggressive buyer, conservative buyer. This is one that we've used with a small customer. And we can basically tell it, you are conservative, and then run it through all these different decisions, like an email send. And then we can tell it you're aggressive, and all of a sudden it's more short-term focus. It's trying to get the best price on that one deal. It's not really thinking ahead. We can start to create these strategies, these agreements. Now, this is really useful because we can put, think about plan, do, act. Think about that as a fractal. So every prompt should be plan, do, act. But your agents can be plan, do, act. You can have a planning agent, an execution agent, and then a validation agent. And you want some of those to be more aggressive. I want my planning agent to be divergent. I want it to be thinking about all different things. I want my execution and validation to be convergent. I want them closing the door on things. I want them, I don't want them getting creative in the middle of executing a very well thought out and solidified plan. So we start to use identity files to do that. And then why I love it is because we can test them, we can version control, we can start to put them in Git. We can start to say, hey, we're going to try 3 different, if you have a digital twin of some sort, you can start to make decisions through that digital twin, test your different identities, see which ones are doing well, which ones aren't. You can have, Git ads. So I love the idea of the identity file helping make decisions rather than rule sets. It is more variable, it's not deterministic, but if you combine it with deterministic tools, you tend to get better parameter optimization. Kind of like I just said, same thing. So most of us make decisions every day. The more good decisions we make, the better. We can compound the number of good decisions. I think it's like that 1% compounds over time. By building some of these skills, some of these agents, some of these harness attributes, by moving things. If I move this giant catalog thing that takes me forever, 3 days to do, if I can move that down and delegate it, I can now run it anytime within 2 minutes of runtime, and then I think it takes like 20 minutes for itself to run. But that's 3 days to 20 minutes. I can do it anytime. I'm going to make a lot less mistakes. It's running deterministic skills. And I can start to do that with more and more of my job. That frees me up with more time to think about what to grow, spend time with people, build trust and relationships, things that only humans can do.
Real quick on that one, Josh. The way I see building all these identities is like, imagine you're in your team, like you're on the SOC team or you're on the operations team, and all these decisions and small things that you have to get done. It's tribal knowledge that you know how to do it, but now imagine you got to hire this kid out of college, no freaking idea what he does. But your team has a set of identities that you can start sharing and skills that you can share with each other. And then everyone can improve on it. Like Josh says, you put it in Git, you can revision, like, oh, dude, this one breaks at this edge case, then you can go manually update it. So what we try to do is, in our company, for example, we've got a bunch of different teams, like a DOW team, an energy team, a NASA team. The goal is that each one of those contracts and the way they interact with their customers might be different, and then they have specific things that, Goki only likes to see things in a very specific way, as we map to the 7120 process with CDRs, PDRs, and all that crap. But we can build tools internally to our team to provide them exactly what they want. And then when somebody new comes on, when we want to scale Rick Graham, because there's only one Rick Graham, you're going to want to be able to give those tools out. So think about that in your own job and your own career, because getting skilled people to come work for the government is not easy. We don't pay enough. Raise your hand if you think you get paid enough. Okay, the BD guy. Dan's like, I'm good. I'm good. So that's just think about it in that perspective.
I'm going to go over this briefly. Just a couple of things, because we talked about a lot outside. We feel like it wasn't complete if I didn't at least mention some of this stuff. With different architectures handle it differently. Like this puts a human in the loop node. You can control it on the edge between the nodes with line graph. Arc is built into every layer. And then with OpenClaw, it's not there at all. That's why it's OpenClaw. But you can put it inside of OpenShell. That's basically what they did there. But you can, so how do I say this without going too into depth? We think everything should be observable. It needs to be observable, and it should be able to be rebuilt through an audit trail and an audit trace. So by creating code in there that executes with audit, we can start to make sure that everything that's done, we're actually tracking and tracing. This helps us rebuild, find problems, then we go back, adjust the harness, fix it, and start to lock things down where we're finding emergent behavior that we don't like. Obviously, there's human in the loop. We've got action letters. I can show examples of that later. What else? Least privileged tools. So I included this earlier. We don't give all the agents tools and access to everything, right? We only give them what they need. We make sure that they're going to use it. They can't communicate. We can cut that off if we want by removing the team. But you want to always, it's basically zero trust on the agentic level. Give them what they need, shut it down. We use cryptographic DID, IDs. You need to use your ID to access any tool. That way the audit trail always has which agent and why. We have every LLM tracked through a trace. So red team, I'm sure Dr. Kalin can go into that quite a bit and talk about how that works. And then obviously we like evals. We like the golden set that we can use over and over so that we can cross compare models, harnesses, adjustments, versions, everything. So what do you need to do this? Like I said, I'm doing this at home. This doesn't have to be a crazy thing. You can download Nematron. You can get a couple GB10s right here. These ones are networked together. Set it up, and you can use what's called a RAID cluster. If you guys have never used RAID, just distributed computing across the multiple nodes. You can you can serve this to locally to where you are, and then you can start to hit it with your agent and start to build some of this or code with some of it. There's a lot of other open models. I mean, some of them are getting more and more powerful. Like I said, some of the latest ones are just as powerful as Opus 4.5 was when it first came out. And so I believe that now the open weights are good enough, strong enough, and I say it because I'm doing it myself, and I'm pretty anal about my development workflow, as you'll see later. But these are now good enough to use. Talk about that. This is basically OpenShell walked around in case you're interested in that. This is a quick thing on ARC. So this is how we thought about it. And again, I hope this maybe inspires you all to think about it. This is our open source, so you can contribute to this. We're still building quite a lot of it and experimenting it. But ARC was built for trust first, not features first. So the idea is that it is secure, that it's simple. But we got rid of all the dependencies. I think we use none of the SDKs. We figured it's 4 agents. We don't need streaming. We don't need any of that stuff. So basically, we just have HTTP and direct calls to the LLMs. We've got a lot of providers that we allow right now. Again, that's what we're using inside. And then there's each layer is separate. So similar to Pi, y'all familiar with PyMono, the mono repo?
No.
No. Come on.
Tell us, Josh.
Everybody said yes except you. Even Dan was like, yep, he's on top of it. Okay, so behind OpenClaw. And so we like, I like that module layer. I like to be able to pull something out, fix it, put it back in. And so we've got, whereas Arc LLM, which is literally just 11 providers, no SDK, all it does is a call back and forth. And it's a unified layer so that we always get the same output. That can then get pushed up to Arc Run, which is our agentic loop. So the agentic loop will call through Arc LLM. There's 3 different loops, I think, that we built. We built one where it's just a loop, one where it can spawn, and then each one of these has one config file in it, and that's where you control everything from the config. So you can lock it down so it has to sandbox before it can run anything. Again, that's all built in there. The agent is the next one up. Agent is all the tools and the harness that we just covered that uses Arc Run, that uses Arc LLM. And then our team is where you create the organizational structure and can throw in a bunch of Arc agents. So we have our team is CTG, and then there's a Brad agent, a Josh agent, a Mosa agent, all running so they can share some of the knowledge as we talk through them in Slack. Again, we treat them like first-class citizens. They have their own security privileges. They're not connected to email. They have their own email, their own Outlook. And so that's kind of how we do it. Arc Mask is just the whole thing. And then this is just a command line interface so that we can do stuff directly from command line if we want. Again, cryptographic ID, deny by default, automate. So in the Arc LLM unified layer, there's automatic PII built in. So again, we basically went through all the OWASP LLM and all the OWASP agentic threat surfaces and try to either mitigate or remove if possible. So again, this is built for trust first. This is not production ready. This is us building, having fun, experimenting. This is how we learn, and it's open source if you want to jump on and play with it. Do not take this as a product, launch it and say we're good, it's secure. I think it is, but it's just our own sort of project that we're building with and having fun with, and I'm sure it's going to get there eventually. And then we're working on our prompt model skill, and the UI is actually half built now, so we can pull up all the traces, we can view them, exact tool calls, we can group by tool calls. The UI is becoming really powerful with the view and manage all this. So to end, well, I think it's obvious. I think I made my case here, but I think what we want is our data. We want to own our intelligence, we want to own our inference. Really, really important with where the world's going. The software, the SaaS platforms are either going to lock you out and force you to use their siloed agent, which is worthless, or they're going to open up the front end and say, we are getting rid of the GUI, or I've even seen companies doing like agent.atlassian.com. So the agent can go there and access and talk to everything directly. They got rid of all the buttons and the CSS that's for us that the agent, is going to waste tokens reading. We're seeing that more and more. We're seeing documents written for agents. Why? Because if the agent can read the documents, the agent will say, oh, this is the right tool. Like people are literally marketing to agents through documentation. So why? Because the people that bring their agents have all the intelligence. It's all going to be inside. We're going to own that ourselves. It's going to be on a system somewhere that you're going to host. Might as well be your system that you own. Put your own inference on it. Then you've got data sovereignty. You've got you don't really have latency because you're not going over space and time. And then you can add all the security stuff you want because you're totally on-prem if you want.
And Josh, can you talk a little bit about the view that you and I have talked about with software as a service platforms that are bolting in AI to their product and saying, hey, we've got AI, which is basically every OEM ever for the last 9 months, and how we view where AI should be. Remember that?
Yeah. I think I might have stepped out. I said, I think it's all worthless because it's silent.
Yeah.
You got to bring your own intelligence because AI is a natural force for context. The more context you have, the better. I'll say it again. The more context you have, the better. So it needs to understand about, and I'll use business terminology, your CRM, your ERP, your strategy, the meetings that you're having, and if all of that is falling into one place, it has enough context to pick and choose from to help make the right decisions and help become an actual useful coworker versus a chatbot that totally forgot what you were talking about yesterday morning. That does not happen when you're using the bot that's in Jira and the bot, that's mildly helpful. Reword this for me. Thank you. I'm glad I paid token money for you to reword something that I already roughly knew what it said. They can't be helpful because they don't have all the context. They only know what you're renting from that platform. So I think the natural the natural move is going to be, and it already is, more and more companies, once they start with this, they start keeping all their own intelligence because they realize the more they have, the more powerful it is. That's why the kids started getting Mac Minis, because they realized the more that I have outside of these platforms, the better. And that was their version of going on-prem.
I think one of the other bigger things is that we have these massive software subscriptions that these companies have bought. And we only might be using like 2 to 5 features within that software. And this gives us the ability to try to mitigate those and free up budget to go get more tokens on-prem. It just costs electricity.
I love unlimited tokens at home. I run that all the time, right from my phone. All right, so you have GB10. I'm gonna let the Dell guys hit this a little bit in a minute, rather than all the time. So this is kind of your stack. You've got your on-prem, an open weight model, inference and serve to whatever your agentic is, could be plane graph, could be whatever. Throw in your identity store to help you make the right, you add your organizational infrastructure, you have make sure you're evaluating version controlling, and then you have make sure everything's passing through observability. I mean, everything. Some people just attach observability to like the LLM part. They're missing where a lot of it needs to be. And again, after this, haven't talked to anyone, go more in detail on any of these. We are using this all the time. We're building it. That's where a lot of these thoughts and ideas are coming from. The specifics we'll get into after lunch are coming from us working with clients and realizing, oh, this in theory works, but not in actuality. So I'm going to leave you with this. We have a whole framework, but I summed it up in like one slide, so we don't have to like spend a bunch of time on it. If you're trying to think about where can I use this, first of all, you don't have to do everything. I know this guy that works with us, and he had like this one really tedious process, and he built that into a skill. And then he's like, you know what, the step right before is pretty tedious, I'll do that. And after 6 months, he had basically built a whole automated workflow that he didn't know how to combine, we combined for him. And so this can start with just solving one small tedious problem of data collection, data aggregation, analysis, brainstorming, whatever it is. And so I wrote these like the 5 questions that we see come up all the time that bubble most of that up. Where do I know repetitive work? Think of yourself saying, every day I have to come in and do X, Y, Z, or every day, you know, she wants me to send her this. Think about those situations. Think about data creation. Anywhere data is created consistently, there's probably an AI opportunity there. When I say data, I don't just mean logs. I mean purchase orders, observation records, summaries of academic papers, research summaries, consolidation of reports, anything where there's data being created in a transaction system, in a blob storage, there's probably somewhere in there some opportunity for AI. Human as middleware. So we talk about that copy and paste. Like doing something that technically there's no human judgment, but we don't quite have the tools to make it work, probably an AI case there. Knowledge transport. System-to-system manual transfers, similar to the human as middleware, but where we are, I'll give you an example, a nurse taking all the details and then giving it to the doctor who then comes in and talks with more detail. Like there's 3 people involved and the same knowledge being tossed around. There's probably some AI opportunity there. And then expert bottleneck. Expert bottleneck is using high-paid, smart people to do low-level work because they need to get something done before they can go do the actual thought work. It's like, I'm all over that. So, so there's usually some AI there.
So in your example about the nurses and the doctors, so in the context of being on a HIPAA compliant network, how are we protecting that data?
So HIPAA has to do with the actual hardware and what it's connected to and not connected to. As far as the workflow,
it's all containerized inside the network.
Yeah, and I know I was just at a company that's HIPAA, and literally they've got a thing here, transcribes, doesn't go to the internet, it's only connected to the
So it's never touching the internet.
Yeah.
Okay.
And then it goes, they use Parakeet to transcribe it, and then they use that to summarize all the patient details and not miss it. I don't know how other ones do it, that's just one example.
But that's probably
where I was,
as long as it's not touching the internet, that's good.
Yep. Yeah, the good thing about having the inference on a system, again, is you don't have to have internet connected to it. You can lock it down because it's literally on the computer.
Building for on-prem has been so painful because all these script kids are
building this awesome stuff, and we're like, we can't do that.
No claw hub for us.
No.
These are just examples. I'm gonna pass through these. I think y'all get the point. So, I'm gonna end with this. I cover this a bunch. This is kind of what I talk about. This is what Brad's referring to. Currently, a lot of times for the last 30 years, SaaS, say you've been renting your intelligence. We are now to a point where you're going to want to own your intelligence. You're going to want to bring it home. And the more you work through the agents, the more it will collect, understand that, and be useful. Now, here's the thing. If we are working through agents in some capacity, they're scanning some of what we're doing and writing it down, or we're literally talking through it. And I'll say I'm Josh Kaler, and I have a team of devs working on some stuff. He might slowly be creating a development philosophy at i3 that he has as he's working. But if he's working through the agent, that knowledge then becomes knowable by others in the company, right? And we're seeing this more and more. The more you work through an agent, the more it's not just like, oh, that was useful for me to recall later. It's now there's others that can leverage that knowledge that wasn't quite high enough on the scale to go write down and distribute. Like we can't distribute 10 memos a day. I'm like, I had an idea. It would drive people crazy. But if it's going through agentic, now all of a sudden it gets logged, it is referenceable, and now we're building that base. So I'll give you another clear example. Our system logs entity files, vendors, customers, projects. We do part numbers sometimes if the company is part number heavy. And so as finance is talking about a part number or a vendor, they can say this vendor is late to pay. Quality is talking about a vendor, right? They're saying the quality is really high on this vendor. And then procurement's talking about a vendor, or it's reading logs from the ERP. We build a full vendor file. So now procurement not only knows what they used to know from the ERP, they know what quality is saying about the vendor, they know what finance is saying. They get a much bigger picture and a much better way to make strategy to deal with that vendor because they own the intelligence. Everything is being collected and then redistributed to the whole team. So now you can leverage everyone else's understanding of a certain entity or situation, not just yours from your narrow view. That's a bit of that brain. Like all power, so what is this possible? These are kind of our main partners. Brad went over them, but I'm going to go over them one more time. CTG Federal for the hardware, the architecting, the engineering, the implementation, the integration, everything from like figuring things out with Bob Baxter to Brandon Moore coming in, plugging in to make it all work. Dell Technologies, obviously we've got these GB10s here, the smallest thing, but like a really quick way to get started. I'll let the Dell guys come up in a few minutes. NVIDIA with OpenShell, and then in this case, these are the Blackwells. And then BlackArc, which is more about the AI engineering systems. And then i3. Dr. Kayla, do you want to come up and talk about i3 for a minute? Sure. You go with that? But after that, don't scare us.
What am I supposed to say? Internet be good. I love AI. Nice to meet y'all. My name is Dr. Josh Kalin. I work for small and mid-size, kind of growing into mid-size company called i3. And what we do is a number of things, training. We do things like build drones, and now we're also in the AI and AI security space. And so that's really about this concept of how do we secure these AI systems that we're now putting everywhere. And I think one of the challenges that you're finding, and you've seen a little bit about it in these briefings, but it's the fact that these systems are being built so fast that we're not actually controlling for a lot of the risk factors that are occurring. I think one of the simplest ones I saw was OpenClaw, where I bought somebody a $3,000 ticket to a conference in Norway because it said, hey, I know you're really interested in AI, so I went ahead and bought you the ticket so I can be proactive. And that's what happens when you provide credit card access to OpenClaw and no controls. And there's a lot of other more scary examples and things we could talk about at a different time, but I really think the reason that I just wanted to come up here and share that with y'all, and I think one of the questions that was made was how do we do this in a defense kind of focused environment? How are we solving those problems? I think the thing and the way that we think about that is we have DevSecOps, how we develop software securely. We're kind of promoting AI SecOps, like how do you actually securely develop AI systems for mission critical environments, especially where you could have weapons release, or on some of the projects I worked for NASA, where you had Cat A missions, astronauts can die, essentially. When you have an autonomous system that's run by AI, you have to make a lot of choices. And you have to know how those choices are made. So the security and safety of the people that rely on those systems is just as important as how you design those systems. So I think that's one of the things that we do really well. And we're both an integrator and developer of a lot of these technologies. And I appreciate CTG and all y'all folks for actually organizing this.
Thanks, I appreciate it.
Then keep talking about Dell.
So I'm Keith McAfee. I'm the Dell Data Center Account Executive that covers all the Army elements at Nextphone. Got part of my team with me here, Dustin, raise his hand. So that's our solutions architect, and then Don in the back is our storage account executive. I didn't want to come in and just talk about hardware because that's what everybody knows about Dell, right? We obviously sell hardware, but we also have what we call the Dell AI Factory, and I'm not really fond of the name necessarily, but I'm not in marketing. Really what it kind of is a framework to kind of help plan, like start at a desired outcome and then figure out what steps you need to take in order to get to success. And so, you know, it's picking a use case, it's deciding if your data is conditioned and ready for feeding into some kind of a model. And then it's if you have the right hardware and software to accomplish those things. So the real thing I want to point out is the 3,000 customer wins since we started this late 2024. And it's not to say, oh, look how great we are, but the point of it is we now have 3,000 cases where we've went into these places and won that. So now we have a lot of expertise in building a successful AI environment of some kind. Just let me just go to the next slide here. I had to bring some notes because otherwise I'll just ramble. Go ahead. I didn't know it built out that way. So anyway, use case wise, if you're just starting on an AI journey, what we've noticed is obviously it's sometimes hard to pry that money out of the contracting officer's hand, right, to get funding for these things. So part of the AI Factory is our services team comes in and kind of helps you figure out, you know, one thing, what would have some high mission value, but secondly, would also be very feasible, right? So I know like sensor data, that kind of stuff, it may not be where you would want to start. You may want to start somewhere a little easier, a little, I guess, low-hanging fruit, and then work your way into some bigger efforts there. And I'll tell you, Dell Sales Chat, we set up our own internal AI. I guess it's been about a year now. But when they did that, what they started with was just our tech manuals, just our server manuals, and what we call our source books. Before I was just a slimy sales guy, I was actually a solutions architect for about 7 years. And so I'd have a customer call and say things like, hey, how many PCIe slots or what options would I have in an R740? Something like that, right? Well, I would have to pull that source book, either copy and paste, and so to what you're saying about the 5 questions, right? That was easy because it was me having to answer a technical question and being that middleman between our knowledge and my customers. So I would have to pull all that down, summarize it, put it into a PowerPoint of some kind, or turn it into a PDF and then send it to my customers. So something like that may take me an hour to 2 hours, just depending. Like for our R740s, for example, there was 8 different PCI configurations you could get on those boxes. So it took a long time for me to put that together, and now I can do it in under a minute. You know, I can ask our sales chat that, and then ask it, we'll put it in a different format. And so it made me more efficient at answering customer questions sooner to I guess, just smooth the whole process out, right? So Dell started with just our server manuals, and then from there they started adding more features and more information into this, and they honestly, sometimes the change in how people do things is hard. So they started requiring us, everybody at Dell, 100,000 employees, everybody had to do 25 sales chats per week. And they monitor that, and you get in trouble if you didn't do them. But what they were really trying to do is if you build it and they don't come, well, then you make them come, right? So anyway, that's the path they started. But now, for instance, we have tools for storage sizing or power requirements. Like when you're building out a stack of servers and people want to know the power requirements. we used to have a tool called Power Calculator where you went in, you took the configurations, put everything in there like CPUs, memory, everything about that server, and then it would spit out what the power details were. Now again, our internal sales chat does all that. So my point of this being is not only have we helped other customers with that, but we also practice what we preach. We did that internally, started small, and then worked our way out from there, added more information into it, and now, 100,000 employees strong, and everyone's using this all the time. And so SharePoints that we had are gone. I don't even know how to look up a source manual anymore without asking sales chat where I find it. So it's really sometimes about taking those smaller steps, but identifying what would be mission, useful to the mission, but also kind of low-hanging fruit or easy to accomplish to prove value. And then lastly, let's see. Go ahead and go to that next slide. Next one. So, like I said earlier, it's kind of a framework more than anything else. So if there's something that you like, Dell doesn't come in there and try to make you change to whatever they think you should be on. What they're really doing is trying to help you figure out that strategy for putting it into place. So for instance, if you like Hugging Face to pull down whatever model or meta, we're not trying to change that. We're really going, what tools do you like? And if you're not sure, our team, and of course CTG, they can work with us on that too. That's the other part of it. This is not some kind of one-stop shop, right? We can bring in partners where it helps, help them architect the solutions. We can just do the server deployment, or we can help with some of the services as well. But at the end of the day, it's about building the solution that fits for your, whatever it is you're trying to accomplish. Let's go ahead and move on next one here. And so, of course, like I said, Dell, everybody knows our hardware. The GB10, super cool box. I'm glad you guys are going to get to see that today. Great for that desktop development. I think it can do, I want to say it's 200 billion parameter model right now. You can daisy chain, it's got a 200 gig connection on the back, so it's capable of doing a good bit on such a small box. But, and as you work your way across this to the right, obviously as you build out a bigger AI or better infrastructure, you obviously look at bigger and better things. And so, for instance, the XE7740 and 7745, one of those Intel processors, the other is AMD. But those start at 1 GPU and can go up to 8. And then we have all the way up to these big monstrosities here that's like a 10U server. It's a whole rack solution. We can do those air-cooled, water-cooled, and again, CTG has access to that entire portfolio just like Dell does. So when you start this AI journey, the last thing I'd like to leave you with is our services team do a 4-hour workshop for anybody that wants one. It's anybody that's looking at this idea of an AI factory that we call it. If anybody's ever interested in that, all you gotta do is reach out to Bob or CTG, someone at CTG. And our services team come in with those experts that have now done 3,000 of these things, and they can sit down with you, maybe help you pick your right POC. They'll look at your data and decide, hey, does it need to be conditioned in any way, or is it ready to go? They'll look at your infrastructure and say, well, for this POC, you're probably gonna need this kind of hardware. And then they'll kind of print out a roadmap for you. So 4 hours and it's free. And so if you're on a struggle to figure out how to even get started, or not making the mistake of getting started and then having to back it out, then it's worth it to talk, right? For 4 hours of free talk, and then from there, even if you decide to not go with the Dell AI factory and you want to build your own, at least you have kind of a roadmap to continue on with that. So, thank you, CTG, for letting us come in here, and thank you guys all for coming. So, thank you.